Once again, I want to thank you, each and every engineer who has been able to spare his or her time to participate for this uh, special webinar for the African engineers. We truly want to thank you from the deepest of our heart, and we believe that it's going to be a very interactive session where we're going to share together on how we can model, do the analysis, and also try to come up with the result and to share some very important features about MIDA Civil. I can see people are trying to come up, so we can just give them some minutes for them to show up. Otherwise, I want to appreciate you so much for those who have been able to make it. I know it's not easy because most of you, we are coming actually we are in the end of the year, so people are focusing on making their reports, coming up with the results, making up plans for the next year. So I know it has not been easy, but I want to thank you so much for this time. As you are waiting for other people, please feel free, feel comfortable, and you may be able to share with us any questions that you have. We have the question tag there. You can jot down the questions and we are going to respond to you. By the way, I'm joined with one of my engineer, my fellow technician from India, and he is actually going to also participate on this webinar, and we are going to do our best to make sure that we are able to meet, or maybe to derive the point, or maybe the goal of this webinar to the participant. So my fellow engineer is called Mr. Nandip Gohil. So he's also on the Indian side. I hope this is going to be a very interactive time. So as you are waiting, please just bear with me. We are going to start soon, as I know time is very important. Let's just hold for some minutes and then we shall start. Thank you. We can't wait. And once again, I want to confirm. Please, can you hear my voice? Am I clear? Am I clear? If you can't hear my voice, please. Okay, thank you. I can see some people confirming. That's really good. If you can hear my voice, please, you can confirm, because we don't want to leave you behind. Otherwise, once again, I want to thank you so much for this time, as we're going to start the webinar. Well, this is an interactive webinar, especially for it's so special for the African engineers. So I know I'm joined with many engineers from different countries, from Tanzania, from South Africa, from Namibia, all over Africa. And I know this is going to be a great chance, great time for us to learn and to be able to share much. So as time is going on, so let's just start. And to begin with, we are going to discuss on the Prestressed Girder bridge using the Midas Civil. So first, these are my slide. Looking at the overview, we're going to have the bridge geometric. That means using the FCM bridge wizard method. We're going to look at the geometric on how to go, maybe to model this, to input the sections, the materials, and the tendon. Then we're going to also check on the construction stage, looking at the section and the tender profile. And we're going to add what you call the time-dependent material property assigned. And I'm going to also input the load that we call the superimposed dead load. And finally, we're going to run the analysis, and I'll be focusing on the construction stage analysis. So I'll be sharing with you the results and especially the main part of this analysis. Otherwise, as we going on, now this is the framework of the bridge. As we can see, we have the three span, and then we have the pier, and they are indicated there the length of the span, and this is the cross section, especially starting from the pier going down. So we're going to have our bridge having the length of 300 and plus the width, and not only that one, also we are going to have the two piers, as you can see from here, divided into 3 spans. Now this is the construction stage or the construction sequence. So we start from the piers. We are going to we are modeling, or maybe we are doing the designing of these type of bridges. We actually have what you call the foam travelers. So the foam travelers, most of the time they actually always input the concrete on the other side. So when we start on one side, while actually we're going to at the end of the day we're going to join at on the other side, means we have the two piers. So you start on one side, creating the construction stage, and at the end of the day, then you have what you call the middle part, whereby it's the lagging. So using the software is able to calculate, or the software is able to handle this automatic. So it means the joining of this lag, it can be done. It's going to be done by the software, just automatic. So this is the construction sequence. So as I'll be demonstrating also further, we also have here the support, providing the support for this type of bridge. So it means at the end of the day, the lagging part is going to be covered by the software. Now this is the construction schedule. This is how it looks like. As we've said, we have the 3 span and the two piers. And apart from that one, now when you look at on the y-axis here, we have the lines. Now these lines representing actually the numbers of days, like for example, like 15 days. So we can see from here now we have the stages like 1, 2, 3 multiplied by 4. It means it's going for the first pier table is going to take 60 days in order to, like, before you make the second pier for the second pier table, it's going to take a period of 60 days to make the second one. So as I said, the line representing the numbers of days, that's 15. As you can see here, we have 4 multiplied by 15, that is 60 days. And also we have the segment. That means each segment takes 12 days. So what does it mean? It means 7 days for the form work, and then 5 days for what we 5 days actually for the curing. So it sum up to 12 days. And then you also have the key segment. It means after each peer has been made, and there is a key segment. So you can see these are not the same. So it means the time difference there is 60 days. So after actually modeling the second peer, it's going to take a time frame of 10 days, and we are going to have the key segment. And these are the tender layout. So we have the top tendons, you can see from here, and we have the tendons being put into segment. That means we're going to input 2 tendons from 6 to 10. And also we have the bottom tender, whereby we only have 1 segment on this side, and the other part we only have again 2 segment. So this is the part of the layout of the tendon. As you can see, it has been anchorage on the top part and the bottom part. So as I'm going to demonstrate to you, I will be showing more on these tendons also based on the construction stage. So without wasting time, I'll just go straight forward to the software. Now this is how our software looks like. This is Maida Civil, that is 2016. So without wasting time, so this is the software. It has several wizards, and then you can see. So before we start, we actually we prefer people to focus on what we call, just a little bit. So before we start, so you have to click the new button there. Then you start to have the new window there. So you can see the wizard. We have different types of wizard here. We have on the nodes, like for example, we have the views, structures, and everything. So before we start, it's actually recommended you start with the works, because it gives you the flow of your work. That means whatever you input on the model, or maybe on the window model, it's actually going to be recorded here. So it's good to start on the work. As you can see what I'll be doing. Now I'll be going to structure, because we're going to design or to make the Prestressed Girder bridge using the FCM. You can see we have several wizards, but I'll be focusing on the FCM. And this is the FCM. As you can see, it has the type 1, there's the type 2. So today we'll be focusing on type 1, and then it has modes, like you can see the section, the tendon. Then apart from that one also, as we are going to looking at, this is the bridge that you're going to design today. So first we have to input the material. It has actually several types of things that need to be inputted. Now, as we can start from here, we have that button. You can click it. So either if you're starting from step by step, you can click it, add, and then you have something like this one, whereby you can put the type of material that you want, or you can choose the type of the standard. Or maybe if you prepare something in advance, you can now import it. Like for example, I'm going to import whatever material that I've already prepared before. So these are the material. I have different types of material. So I'll click it OK. It's already applied on that part. Then checking on the section also, because also if you're going step by step, you can click add. But now I'd already prepared in advance. So I'll just go to the one that I prepare, and then I'll just select only one section, that is the pier, and then I click it OK. It's already applied. So you can see here we have different types of material, and then we have also the section as only one section, that is the pier. And the numbers of the pier, as you can see, we only have how many spans? Those are 3 spans. So we're going to have 2 piers. And how about the stage duration? We're going to put 12, as you can see, as you've seen before, representing 7, the numbers representing the formwork, and then 5 representing the curing. And we're going also to use the method of the cast in. Now, if, for example, you're putting the radius for the curve, especially you want the graph to appear in curve, you can now put the radius. You can choose either convex or concave. But now we're just going to focus on a straight bridge. And we have now the peer table. So you can input the number that you want to input here, but I'd already prepared for this part. So I'll just import it. So I'll just import it, and you can see now we have the peer table there. And this part here, actually, maybe it may look a little bit complicated, but with the help of the diagram, it will help you to understand where is the peer table, where is the base, and everything. So when you import the K, like now this is representing on the outside part, the exterior part, the exterior zone, and this is the interior zone. So you input the data, and also after you finish, because it's actually symmetrical, you can see from here the FCM is actually the same. And for the zone also, for example, if you don't want to put the data like that one, you can now use the advanced. And you can see for us, we only have the peer table tool, 1 and 2. So if you want to put more peer table, you can actually use the advanced feature to input the other peers. But now we are not focusing on that, so we don't need to struggle on that. And also for the key segment, also if you want to put also more, like now we only have 3, you can also add more depending with the numbers of the segment that you want to put. Applies also with this part also for the zone, the same thing also. You can see this is what we have already inputted. So if you want to put more, so you can add more zone on that. But now this is really not important for us. So after we've done that one already, we can now check on the peer table placing. You can see there we have the peer table. Now, as you've seen from the presentation, I showed you that the first peer, the time difference between the first peer and the second peer is 60. So if maybe you want to put maybe another time difference, you can put here, just select, and then if you have several peer table, then you put the duration. But already it's 60, so that one is okay. And then how about the member age? So this part is very important because it helps you to understand the time of the curing, or maybe at what time the bridge is going to gain the strength as you're going to put the loads. So for the FSM, we give it the days, that is 60 days, the key segment at 10, and the peer table takes 15. And for the segment, it's 5, and for the peer now, it's 100 days. So after we've done on the mod part, so we're going to the section. Now the section also, because as you can see from the beginning there, I imported, so it means it's already applied the automatic, or you can import whatever section that you are to input. And this is the diagram here. We can actually view it. You can see this is the drawing. And apart from that one also, for the form traveler load, you can include it, and also we can include the weight concrete load. So you can put the numbers of the force that you want to put there and the intrusive. So as you can see from there. And then let's look at the tendon. Tendon now also we have to input this one. You can import it, let's say manual, or you can import it by, let's say after preparing, then you can just import it and put it. You can just be automatic. Now let's look at the tendon, because we have the different types of material. So we just click it, add, and I'll start with the top tendon. Now for the type of the tendon type, we have actually different types of tendon, like you can see here, the internal pre-tensions, the internal post-tensions, and the external. So today we'll be focusing on the post-tension, that is internal, and the material type, because already we had inputted before, that is tendon, and we have to put the total tendon area. So just click this one, then we choose so okay, we choose that one, and then the number of strange, that becomes 19, and you click it, apply. And then it's actually recommended to use the CEB, because it gives the best result. So this one, and also we have down here like the units. You can change the unit, for example, whichever unit that you have, and you can apply for the curvature friction, and then also the wobble friction factor. Maybe I can put it to, Yeah, you can just leave it like that one, or you can change it. And then we have the beginning and the end. And the bonding type, either you can say unbonding or maybe the bonding. So click it OK, or just apply, because first of all, okay, it indicates there's some error. Let's see what problem do you have here. Okay, so I did not put the dactic diameter. I can say that one is 0.103, and we click it apply. It's already applied. You can see it's already applied. So we're going to put now the bottom tender. It has the same values. I'll just change that one, 0.2, and you click it OK. So we have already the tender, the top part and the bottom part. So just close this one. Now already we've put the tendon, then we have, let's see the number of the tendons. So it means it's equal. Then for the N1, it has the 7 tendon, N3 it has 6, and then N5 has 2, N7 has 2, then N2 has 3, and you can see. So these indicating the numbers of tendon that have been applied on the numbers of N. So that's okay. Then let's look at the jacking stress. So for the jacking stress, as you can see before, we had the yield strength, and also we have the ultimate strength. So you can choose whichever strength that you want. You can put the 0.72 for the ultimate, or you can also put for the yield. And let's look at the top tendon. Okay, from here, like for the, let me just show you on the presentation. You can see the top tender we have 2, so it means the 2 tendons being applied on the 6 to 10, and then for the bottom part, that means on my left hand side it's just 1, on my bottom right there are only 2. So we have to apply this one. Okay, this one tells me I have to save my model. So I just say tests 2. I'll save it down. So I already apply for the top part, that is the peer table, that is 2, and then from for the remaining one it becomes 2, but for the 6 up to 10 we only have the 2 tendon. So that one is okay. Then for the bottom part it's only 1, apart from this one becomes 0, which is already applied also. And on the left hand side we have 0, it's only 5 and 11. Those they have two tendon. And then this part also is very important, like after each construction stage, meaning there's what we call growing. So you can put like the change of the tendon, let's say after every stage, or maybe after 2 stages. So it depends on what you want. And here is the anchorage position. So for example, this is the cross part and this is the length. So especially is the distance is just between, you can put a fraction between 0 to 1. So for this anchorage position. So we can see now everything now is applied. So this is what we call now the FCM bridge wizard. So we've already put our model. We have the 2 numbers of piers. The section is already applied there. We also have the tendon. Now you can save this one. When you save this one, you can actually use it later. So it means later, maybe when you want to actually model this kind of bridge, you don't need to input the data again. You can just save it, and then later on you can actually just use that wizard to help you now to save your time. So now we've already made the wizard, so we just click it OK, and you're going to have the model. So that's the important, or maybe it's the important of the wizard. It saves your time. As you can see now, I'm very sure that if you are told to model this type of bridge, the Prestressed Girder bridge, it will take, maybe for some people it will take like years, or maybe it will take a lot of time. But using the wizard, so this shows how the power of the wizard is. So it means already the wizard has already calculated. It has already put the tendon, the loads, and then the boundaries and the support. So first, let me just say select this one. I'll select first of all the tendon point. We need to check on that one, and the load I'll just check on the nodal load. So you can see Those are the nodal loads, and you can actually view the tendon being applied already automatic. So let me just view it from the first construction stage. So I'll just use that one. So to view it, just click it and scroll it just forward, and you're able to view it. Now from here, you can see this is the formwork load that's been applied on the pier, and this part here is the moment. And now we have the two tendons on the pier segment, you see. So as you scroll down the construction stage, you are able to see how it's actually been applied. So you can see the moments, the tendon, and also the formwork load, you see. So let me just put it front view, as you can see from there. So already from each construction stage, as you scroll down, you can see how it has been applied. And this helps you to save time when you're using the wizard. You can actually do a lot of things and come up with many project activity. So now I'll now go to the loads. I'll put the before putting the loads, I have to put the time identity. So I'll just go to the property, or you can just right click it and go to property and choose the time dependent material, the creep and shrinkage. Or you can just use the property, you go to the creep and shrinkage, the compress strength, and then material link, and then the change. Or you can just use the mouse also, it will save your time also. Click it add. So we have different types of material, so I'll just input the value there. As we said, we used before, that is 1990, that becomes 4,000. And then the notational size of the members, it's 1. So whatever value you put here, the software actually will calculate everything and put the right value. So it's another advantage that will help you not to actually to worry. Means if you're not sure with the values, you can just put in any value, and the software will just calculate it automatic to input the correct values. So for the normal or rapid hardening of the cement, we select that one. Then for the beginning of the shrinkage is after 3 days. So we can show the result. You can see from here, we have already the table, the creep coefficient. We'll just apply. Okay, there's something here actually, and it's very important. You can see when I click it apply, it doesn't apply. Why? Because on the first part here, you cannot apply the time dependent material on the construction stage. You can only apply when you have the base. So it means I've got to restart on this one. I'm sorry for that. So I have to make sure that I'm operating on the base level. So I'll just go again on the property. So you have to remember. So the good thing also with the software is that when you make a mistake, it tells you. You can see from the message window when it was telling me that you cannot input the time dependent on the construction stage, but you have to input it on the base. So once again, we have that one. Then 4,000. 1. Show the graph. We have the graph there, and we can apply this one. We put for the second material. Okay, we have it there. Show the graph. We have it already, the graph of the creep coefficients. And it's okay. So already we have the two material being applied. You can see, as I said, from the work there, the work actually helps you. You see, whatever you input, it helps you to show you. It shows the step that you're doing on the modeling part. So you can close this part, and then now we're going to put the compression and strength. Click it add there. We have the two types of material. Now you can use the code or you can use the user. So you can have you can prepare this part, just copy and paste and bring it here, and it can be able to be applied. But now we're going to focus on the code. So as I said before, this is the best. The CEB is the best code, give you the accurate result. And for the For the main comprehensive, we can just put that one. Then we can redraw the graph, looks like that one. Then we go to the second material. So the same thing also. We can also redraw it. You can see from there. We click it OK. So already we have the time dependent material, creep and shrinkage, then the compression and strength. It's already been applied. So blue here indicates the color blue indicates it has not been applied on this model yet. So the black one means everything it has been applied. So next we're going to look at the material linkage. So try to assign it to the right part on selected material, and then just click it add. And the second type of material, we have it add, then you close the part. Okay, so then next we're going to actually the change of the property. So before I go to the change of the property, I need to put some load on this one. But before going that one, let me just go to the change of property. So I'll just remove this one first. So I'll just go to the display and uncheck it. That was the nodal load. The other one was tendon profiling. Just uncheck it to make it work easier. So now we're checking on the change property, means now we're going to assign it to the model. Okay, so this is the notation. So first we have to select everything there. Select all, and then you just click it apply. So it has already been applied. You can see from there. So everything, it has already been applied. So that is the most important thing of the work tree actually. It helps you. It's like a diary. It gives you the step, every step that you input on the model, it actually shows you there. So you can see the property, the material, the tender, the boundary, they've already been applied. Now next I'm going to actually to input the load, as I said before, the superimposed loads. So we have the element loads there. So before that one, let's go to the load case. So this it has already been applied by the wizard. So it means I just have to add only one type of the super dead load. And since it's a construction stage, I'll just choose the construction stage. The construction stage there, just add it there. Close this part. And then let's go to the load group. We need to put on the load group the same load, that is the super dead load, superimposed dead load. So just click it add. You can see it's already added there. Now we're good to go. So as you're going to put the beam loads, I'm going to apply it on the superimposed dead load. So the name of the group, that is a superimposed dead load. And then on the direction of the global Z, and I'll put this one as a minus 3.42. And before I proceed, I have to select the beam part. So I'll select by single. I'll select by single. So you can see I've already selected by single. And then when you click it apply, it has already been applied. Pop. You can now view the beam loads already. They've been applied. So it doesn't take a lot of time. You can see from there. So I will now show you how the load that I've applied at the beam load, how we can actually use it from the construction stage. So first, this is the construction stage number 1. The time duration, it shows you the stages and the name, and the duration, that is 12. That means 7 days representing the form of work, and the 5 days for the curing. And then it also has the element. We have the element, we have the boundary, we have the loads. And apart from that, it has also the activation and deactivation. So what do you mean by activation? Meaning the parts that you want them to be applied in the model, so you can activate them. But the unwanted part, you can select them and deactivate on the other side. So the software does it automatic. So for example, let's look at this part. We have the boundary. It has already activated this part, the support. Let's check on the load. As you remember, we had put the loads that at the beginning. So it means this construction stage 1, for the wet concrete load, it will take after 7 days, you see. And let's now check on this part. You remember the pier, we had put the pier how many days? 100 days. And then the group, the 15, the group 2 also 15, and the pier 2 is also the same because it's symmetric, it's 100 days. So the software has already actually activated automatic. So I didn't do anything on that. Now we can also scroll down and check for the group 2, the same thing also. We have the boundary there. The loads you can see. So the deactivated loads means the unwanted part, it has already been deactivated on this. So the software does it automatic. So it helps to actually to avoid error, because when you do this kind of modeling manually, you come up with a lot of error, because this is an IT based software, so it helps to do everything accurately based on itself. So when you scroll down, you can see the type, the elements, the activations, the type of the load, the one which have been activated, the one which have been deactivated. So it's automatically been applied by the software. So I'll be focusing on the last part, and this time I want to put the duration of 10,000 days. So the reason why I'm putting the 10,000 days, so that I may be able to see the effect of the creep and shrinkage. So, and I'll actually apply it on the superimposed dead load. So I'll just say activate it on this other side and click it OK. Check it on this other part there. It's already applied. So it means everything now it's okay. So it means after 10,000 days, I'll be able now to see the effect of the creep and shrinkage. So this is really important. Now, having everything done already, so we had the loads, we had the boundary. You can see here also, okay, we have the boundary here. Let me just show you. Just right click it and then you display. You can see the boundary. You can view it by rotating at any angle that you want. That's the good thing also of having several types of icons that helps and easen your work while you're doing the modeling part. So try to right click it and display. So it means everything has been applied. Now, before we perform the analysis, we have to actually check to confirm for the construction stage. So this is the construction stage control data. First, let's look at the time effect here, time dependent effect. So whatever we've input there, the creep and shrinkage, we have it there. The convergence for the creep is 5. And then, so this is actually the tendon tension loss effect for the creep and shrinkage. So we have to, it has been checked already automatic by the software. So I didn't touch anything on this part. It means the software already has actually confirmed it by itself. So because this is by default, I just leave it the way it is. Now on this part, so we have the final stage for the last stage, and then the time dependence, and we have the cable tension for the force, for the internal forces. And then I would like to consider the initial tangent displacement for the erecting structure. So that is all, and then save the output of the current stage. So as you confirm on that one, then the beam section property, we have the change with tendon. So it's okay. So now I'm ready to perform my analysis. So we have the performing analysis. We have the two buttons, by the way, of this part here and this part. So it's same function. So let's see how long it will take. So down here, you can see we have the message window. It will actually show you, this message window helps you to know whether you've made any mistake or you are on the right track. So now it's running the analysis and it tells me, you can see the message window gives you the information. If you made any mistake, you can see from there and you're able to correct it. So let's see how long it will take to run the analysis. Well, you can imagine that is that is what 13.34 seconds, and the analysis is done. Now I'm very sure if you're doing it manual, you take a lot of time, or you're using, let's say, other type of maybe program, also it will take a lot of time. But imagine, so that is the good thing of using MyDecivil. It helps to save your time, because always time is very important. If we can actually be able to save our time, then it means then we can bring a lot of development in our country. So it's already the analysis is done, and the time taken there, you can see from there, is 13.34 seconds. So you can imagine, if we are doing a lot of project using the program, then we can come up with a lot of good result. So let's check on the result. So we have different types of result, but first I'll check on the deformation. And for the result, I have to check, let's say, on the first construction stage. I'll check the deformation. Let's check on the result as a displacement contour. Now we have the load case here. We have the dead loads, the tendon primary, creep primary, shrinkage. So it's more advisable to use the primary for calculating this type of the contour. Now, or I can just choose the summation. Then we have the step. For the first step, maybe if you've used the user define, you can use the user step, or the last part now. So you can view the result according to the step that you're given there. So let's check on the first step. The components, we have this one, and then the type of the displacement, the contour, and then you can say also deformation and the legend. Click it apply. You can see. So you can view this is for the first stage. But looking at this one and the result doesn't seem to be real, so let's make it real. Let's look at the deform. Let me just put there 0.5, make it real. At least now it appears, now it's okay. So now this is the legend that will give you the result showing the maximum deformation and the minimum deformation. Now let's say try to view it. Let me try to view it on the user step. So user step, it will actually decrease. You can see. Now if I proceed it on the last step again, it keep on decreasing. Now you can also view it each stage. You can just scroll down, you can see. Just scroll it down, and you come up with something like that. So, or you can actually check any types of loads that or load case that you want. Now let's check on the current step displacement applied. So this is the current step displacement. You can roll it down and see it how it appears, and you have the result on the other side. Okay, and then let's check on the last step. Let me uncheck this one. Just click it, the stage step. So you have that one. That's how it appears. Okay. And this is what actually we term as camber stage. So you can actually see it. That's the camber stage. So you have the value there. Now we can now check the clear result of the camber reaction. So we just go on the result, then you go to the camber reaction there. So since you're dealing with a FCM, so we're going to go to the, by the way, FCM, that is a free cantilever bridge, or you can also say free cantilever method. So just choose the controlling part, the bridge girder element, it's already selected, supported nodes, the key segment, click it OK. Then next, we're going to check on the graph, the FCM camber graph. Now you have different types of loads here. You can choose any type of load that you want, and you can come up with the graph, but I just want to check on the summation. Just click it OK. It brings up the graph. So this is the camber graph, as you can see from there. This is how the camber graph looks. So I just want to select only one some part to explain the result. And this is how it looks like. So we have the two nodes here, the bottom nodes and the top nodes. So the top nodes, these shows the formwork that should be considered when actually you're doing the camber. So what camber need to be considered, like the formwork. And this one, the bottom part shows now what should be actually, like how the deformation is going to appear after you've removed the formwork. So that's really important anyway. As I said before, when you're considering what should be considered on the camber control, like the formwork, and then after now, meaning after you've removed the formwork, how is the deformation going to appear? So this is the meaning of the bottom and the top part. So just right click it and then zoom all. So that is the camber. And then after we have the camber reaction, we can actually check on the tendon graft loss. Now these are the tendon you can see from here. Just choose the top one. Now we have the tendon there for the construction stage 1, and we have the animation. You can see from the animation. You can record this one if you want. You see, it shows you how it moves on the based on the what you call the accumulative deflections. You can see from there. So that's the camber. We can just remove that one. Already we have. So then next we're going to check on the girder, the bridge girder. So we have different types of steps. So before going to this one first, I'll close it. I'll go to the result table and check on the tendon. So first we look at the tendon loss. Now these are the tendon loss. You can see there the stress after immediately, the elastic deformations, the creep and shrinkage, relaxation losses. Now you can choose the type of the stage that you want to see. Let's say the last stage. Click it, apply. Now it gives you the value, you see, for the stress, for the creep and shrinkage, the stress elastic. And by the way, you can right click this one and export this one to the Excel. So this will be very vital for the engineers. Or you can also come up with what you call the dynamic report table. So it's very, very compatible, meaning the software is compatible with the MS program. So if you want to export it, this one on the Excel, you just click it and it be exported on Excel file. Now we can also on the tendon, we can also check on what you call the tendon coordinates. Now these are the coordinates for the tendon. This will help you to create what you call the tendon profile actually. So we have there the number of the coordinates and the direction. And also let's check on what we call the tendon stress limit check. So from here we can actually check all, and then it will actually come up with the result. So once again, as this one goes on, if you have any question, please just say, don't hesitate. You can actually jot down the questions and we'll get back to you as soon as possible. So it's still it's opening up. Now this is the tendon. We're going to check the limits of the tendons. So while it's running down, so I hope everything is clear on your side. Okay, it has already opened. So we're going to check it. Let's say check it all, confirm it all. Then you have now. You can check now at the anchorage, the type of value. You can input the value there, and then or maybe away from the anchorage, or maybe at service. Click it OK. Now it's going to. You can see it from there now. The tendon stress, and then we have the tendons limit. So they've already been applied. So that's all for the tendon. I've not left anything out on this. Now we can now check on the construction stage. Let's check on the elements property at each stage. See, you can see at the start of the stage, at the end of the stage, you can see the element property for the stage 1. And you can also see the static elastic, or maybe the end of the elastic cumulative shrinkage. And finally, you can see the creep coefficient. So that's all for the tendon. And then finally, I want to maybe just remove this one. Go back to the model. Okay, so I'll just go back to the initial model. Now already we've seen that one. So next, let's look at what we have seen the camber. We've seen the what you call the tendon loss. Now you can also check other results. For example, the beam diagram. You can choose the types of the load that you want to check the result. you can choose the component, the display option, whether the line or maybe the solid. The scale also you can increase or decrease, and you have the contour. Let's put the deform and yep. I click it apply. It's already applied. Let me put the deform so it appears like that. Now let's check on summation. Now let me check on the solid part. Applied. So because it's deform, okay, let me remove the deform. So that's how you apply on the deform. That's how it looks like. Now without the deform, how does it look like? So it looks like that. So you can see the result on the right hand side where we have the legend. It shows you the maximum beam diagram forces and the minimum you can see from there. And you can actually generate what you call the dynamic report from this one. So just right click it, go to the dynamic report image, click it OK. Okay, let's go to the report now. You remember it's the beam diagram. So go to the tool and we have the dynamic report, generation of the dynamic report there. Click it OK. Now you have what you call the MS file. So we just actually drag it and there you are. So you can save this one and send it to the engineer. You can actually use it for other functions also. So having looked at that one already, now we are actually we've seen the result. So let's go back again to the result here. We can check on the stress. In this case, let's check on the stress on the beam stresses on the PSC summations. So you can choose the section position, or you can also choose what you call the components, any component that you want, and you can choose either line or load. So just apply the solid, then the legend, then click it apply. So it has already been applied. So you can see that's the shape that we had for the pre-stressed concrete. Now that's the diagram. You can view it at any angle that you want. And then let's check on the bridge girder. So you can change actually. Maybe for example, you want to check the different types of load cases. You can actually check. Let's check on this one. So we're supposed to have the diagram. First of all, okay, before checking on this one, we have the result there already. We've seen this one. So for the diagram, okay, so you can also check, let's say for example, for name it, just let's say on the Z direction, you can increase the scale factor. Oops, that doesn't appear, so you can just check on that one, or the position, depending on the position. So you have the position there. So finally, so this brings us to the end of this presentation, and I'm very sure that it was you've get something from it. So once again, I just want to emphasize on the wizard and the software. It saves your time, as you've seen from the analysis, and then it's also help you to model your diagram as quick as possible. So once again, thank you so much for your participation, and truly from the deepest of my heart, I want to appreciate you, and I believe that we're going to have more and more interactive webinars like this one. And then also, please feel free that if you have any questions, any technical questions, you may actually send us in advance. We may prepare the webinar based on the request that you give to us. So this was more general demonstration. So if you have a like particular topic, you may send us via email and we'll be able to respond to you. Otherwise, I want to appreciate again. Thank you so much for your time.